Good afternoon, everybody. Thank you for making time to attend today's Thirsty Thursday webinar. Pleased to introduce Jeff Haber with True Light Glass and Aluminum Solutions, who will be giving a presentation on the ASTM updates related to insulating glass.
Is now joining.
A couple of housekeeping issues before we get started. If you could please all keep yourselves on mute for the presentation, that will help with some of the background noise. We will take questions at the end of the session.
Matthew Miller
is now joining.
As you do have a question, feel free to use the chat function on the Teams.
Is now joining.
Feel free to use the chat function on
Is
the
now exiting.
on the Teams platform to submit your question, and we will address those again at the end of the call. So to get started, Jeff Haber is the Director of Technical Services at True Light Glass and Aluminum Solutions. He has a mechanical engineering degree from the University of Minnesota. His experience totals 30 and more years in the glass industry, working in R&D and technical services. He has expertise in coated, tempered, insulating, and laminated glass. Jeff plays several leadership roles and is a very active member of ASTM, ISO, IGMA, and NGA. Jeff's focus has always been aimed at supporting customers with technically through product selection, explanation, and problem solving. Jeff, welcome, and I'll let you take it from here.
Okay, thank you, Sarah. I see we'll have a few announcements coming in and people coming in and leaving, so little technical difficulties on this first time using Microsoft Teams, but we will bear with us, please, on that. We'll get through it. I don't know if you want to talk about, Sarah, the
unknown
upcoming things on the webinar here. If there's the annual conference coming up in La Jolla.
Is now exiting.
Thank you for pointing that out. You'll see on our calendar events, we do have 2 more Thirsty Thursdays scheduled through the rest of the year. Our annual conference is taking place in La Jolla, a 2.5-day event focused on a lot of our technical and advocacy related issues. And then our 24th annual BEC conference is being held for the first time in Nashville in 2020, and we hope to see you there as well. That will feature programming geared towards glazing contractors and also a small tabletop display session. So stay tuned for more information on our website, glass.org. Registration is open for annual conference. BEC registration will be opening very soon. Thanks, Jeff.
Okay, great. Thank you, Sarah. So we'll move now into the presentation. I have several topics I wanted to cover. This won't be too long of a presentation, but I wanted to kind of give an overview of a little bit of what the standards are that cover insulating glass performance, and also we'll talk about ASTM in general. I know some of you probably have had some experience with ASTM. Many of you may be members, but I wanted to kind of go over how ASTM is structured and some background on it and why
is now joining.
Why it's used. And then we'll get into some of the current task group activities regarding the standards that have been recently updated. And I'll talk about the updates and then give you a few takeaways on those updates. So that's kind of an overview. Let me move on to the next slide here. I've kind of subtitled this as herding the cats at ASTM. And the analogy here kind of goes towards
141966662,000 is now joining.
Sorry for these interruptions here.
+12069537452 is now joining.
I think we're herding cats with this software as well. But anyway, we're herding cats at ASTM. The analogy for cats extends to not only members who are involved, but also the standards themselves. There's a lot of standards within the organization. As you can see my cursor moving around here, E2188, that's a test method standard on insulating glass. It's an accelerated test method to accelerate weathering on units. E2189, this one down here, is a test method also, and it's focused on evaluating potential chemical fogging inside an insulating glass unit. And then E2190, this one that goes vertical here, this is a standard that ties those first two together. E2188 and 2189 are tied together with this specification standard, E2190. It also adds in the test methods for gas measurement and gas filling. These other two standards that you see in the presentation here are E2269 and E2649. Those are gas measuring standards, and they are used by the E2190 standard as well. There are a couple others within the task group that I chair that pertain to insulating glass units. That they're mostly on use of measuring frost point of an insulating glass unit. But again, the herding of cats or herding of these standards, number one, but also
+18124499567 is now joining.
Also herding in the members within ASTM. And I wanted to talk a little bit next about ASTM, and that's in this slide. ASTM is an international organization. It used to be just ASTM, which stood for American Society of Testing and Materials. And today it's now referred to just as ASTM International. It is an international organization that has standards that are referenced in 90 countries around the world. There is participation with about 140 international countries around the world. Most of it is in the US and Canada, but we do have a lot of participation. There are 154 technical committees, of which E6 on building performance, and you'll see that here. That's the one that these IG standards come under, is E6 building performance. That has about 1,200 members in that main committee, as it's referred to. And then under it is a subcommittee under E6 that is called E0622, and that is the name of that task or subcommittee group is durability performance of building constructions. So they're dealing under building performance, they're dealing just with durability issues in E622. And under that E622, there is a task group, or there are 4 task groups, of which the one I chair on sealed insulating glass, that's E62205, is one of those 4. Another one is the E62202, which is on gas filling, and that's chaired by Randy Ernst of FDR Design. Each of us has about 45 members in that roster, and I didn't mention it, but the subcommittee under E6, the E622, has about 231 members. So you can see, and I guess I would say that I least all of these members, because all of these members have a vote. Well, I don't say all of them do, but most of them do have a vote within E6. I'd say not all of them do, because if there are multiple people from one company,
+17404396428 is now joining.
Only those members that are, only one company has a vote in E6. So that's kind of the structure or format for ASTM. I'm with all these interruptions. Get somebody who's not on mute now. Well, let me move on to the next slide here, which is kind of a repeat of that previous slide, but I wanted to reiterate. The main committee is E6 on performance of buildings. Under that is a subcommittee E622 on durability. And under that, there are 4 task groups, of which 2 pertain to insulating glass. The one is mine, which covers sealed insulating glass testing, and the other one is on gas filling, that's covered by Randy Ernst. So those are the committee structures that pertain to insulating glass. current activities within my task group on insulating glass, there are three standards that cover the testing, and I reviewed those earlier on. The E2188 is the accelerated weathering test method. E2189 is the chemical fog test method, and those are both tied together by E2190 specification. Now you'll see at the end of sorry, there something happened there. At the end of each of those, there is a 10. That meant that was last approved in 2010. When you'll see in the ASTM standard, you'll see it usually an alpha character followed by some numbers and then a dash and then another set of numbers. This last after the dash is the year in which that was last published. Standards have to be renewed the renewal period is after 5 years, they have to be up for renewal. And there's
+16473826112 is now joining.
So really within an 8-year period, the standard has to be either reapproved or revised.
+16473826112 is now exiting
By members. So these renewals for all of these three had to be completed by the end of 2018 last year. And we were given goals by members and industry organizations that we wanted to tighten up the tolerances and the procedure in these standards. I should back up that these three standards are the primary ones that are used for certification testing of insulating glass units. But regardless of who you use for your certification testing, it could be IGCC, it could be NAMI, it could be Keystone and ALI. They would all use these same ASTM industry standards. From what we had heard, there was a lot of concern about that some of the tolerances weren't as tight as they could be. Some of the procedures need to be more clarified. So the goal was to do that tightening up and reduce lab variability. We were hearing that some labs had different results than others, and I don't know if that was actually happening or not, but the message was we need to tighten these standards up. And I have to throw up this other picture here of this cat that's working on it, because all of those members that you saw, there's 45 members in the task group. There's I forgot, was it 231 that are in the subcommittee. They all have different ideas on how we should be fixing these standards. How should we be improving them? And it really was kind of herding those cats to make sure that we got the job accomplished, because there are different ways, approaches to how to do that fixing of the standards. And we did end up with being able to accomplish the task, and we'll talk about that here next. Regarding the 2188, that's the accelerated weathering test method. This test method, just a little bit of background, it uses two different weathering chambers. One is a high humidity chamber where the units are inserted at 140 degrees Fahrenheit and at roughly 90 to 100% relative humidity. So they're in a very wet environment. That's done for 2 weeks. After 2 weeks, they are pulled out and put into an accelerated weathering cycle chamber where the temperature is cycled from roughly minus 20 degrees Fahrenheit up to 140 degrees Fahrenheit for a high temperature. Within that test, there is also water spray that's added on the warm side, and there is also UV radiation added to really stress those units, the seals on those units. What you'll see here on the right here on this diagram is a schematic of what one style of chamber actually looks like. It's a little difficult to see because these are all cross-sectional drawings, but you can see that these are there are 12 units that shows in this image that are installed on one side, and I think 12 on the other side, with water and UV applied to each of the units. Anyway, that's the actual test method. and the chambers that are used. The concern was that this test method it was created roughly in the 70s, I believe. So we're talking a methodology that's almost 50 years old. And this original chamber that you're seeing in this diagram, a lot of people found it difficult to service. You have to have a chiller and compressors that bring the temperature down to -20 and then take it back up to 140. That's all done within a cycle of about 6 hours. And if you're doing that day in, day out, I've forgotten now the number of cycles we do, but it's roughly a 17-week test that it takes. You go 2 weeks in the high humidity and then 9 weeks in the cycling and then another 4 weeks in high humidity. And that really puts a strain on this equipment because it's running all the time. And so people have renewed these or revised how this is done. And one system used essentially instead of a chamber, it put them all into a big room on the walls of a room, and a room chamber essentially. And rather than putting water spray on it, which is difficult to remove, they elected to use steam. And whether or not that actually is equivalent, there was a lot of debate by members as to whether that was equivalent or not. Very difficult to kind of do an equivalency test on this type of a measurement, but after a lot of discussion and a lot of hand-wringing over this, we decided to allow steam, mist, or spray as an introduction of water into the chamber, as long as the specimens are always wet during the humidity phase. So it was thought that regardless of what that introduction method of putting moisture in, as long as you had the units wet all the time, it was going to be equivalent. We have yet to prove that out, but that's what was proposed to be into the standard. I mentioned that there's UV introduced into the chamber as well. Those are done with UV lamps that you see an example of one here on the bottom. These are black light lamps. And again, these were specified back almost 50 years ago. These are no longer made in the US anymore. They're made overseas in Asia. And the quality of these varies quite a bit in terms of their output. This specification, or the standard had a very loose specification on this. We've tried to tighten that up a bit. We still have more work to do that, but this is kind of an interim step to tighten up the UV limits that are now more tighter for the laboratories. We also wanted to allow other UV meters. It is required that these bulbs be monitored with UV meters routinely. And there was one meter that was cited. That's kind of showing it here, which is an old analog meter. There are other digital ones that are a lot less expensive and are just as reliable and repeatable. And we're now allowing those other meters as long as they meet certain criteria within the standard.
Is now exiting.
We also revised the figure a little bit. There was some stated requirements on this chamber dimensions that we took off of here. And those are now a little more improved. There were also corrections made to some of the chamber figures that were just incorrect. I think there were some numbers that were blocked off when they got transferred into the publication. And there were various other clarifications also made on E2188. The number of cycles was measured rather than days. We used to just go by number of days, but there were 4 cycles in a day. And so if the chamber broke down for any reason, then do you just count days or half days? So now it's saying that you have to meet a number of cycles, not just days, that are now the requirement. That's helped to clarify more consistency into the standard. Also, there was some confusion on frost point measurement. Frost point is how you tell if a unit has failed. It chills the surface, and if there's moisture inside the insulating glass unit, it will show up as either frost or water on the inside surface. you're now allowed to test that for up to 7 days after removing it in the chamber. Some desiccants are slower to absorb moisture than others. Some of them are in a desiccant matrix. Some of them are inside of a foam spacer, and it takes longer than typical loose desiccant to absorb all the moisture. And so we have allowed that to have up to 7 days to check for frost point. So that's what happened in 2188. 2189 is the chemical fog test. This is a test that determines if there's anything inside the insulating glass unit that could be outgassing and then leaving a unsightly fog on the inside of the glass, or a fog in the airspace of some sort. Often insulating glass units will have, they obviously will all have sealant, spacers, and desiccants in them. Those could each have a component that might outgas. In addition, internal components are installed, such as Munson bars or art glass, or things like window shades or blinds could be inserted into the airspace. And all of those have a potential for outgassing. So this test is to check for that. It's a 7-day test. You typically put 2 specimens of 14 by 20 inch units into this box, where there's a UV lamp on the bottom that heats up the box, brings it up to 120 degrees Fahrenheit. There's a fan to blow around to get to monitors, or to create a more uniform temperature in there. After 7 days, sorry, I should mention also there's 2 chill plates, one on each of the specimens that are inserted there. The chill plate is held at 70 degrees Fahrenheit. Again, the box is 120. That runs for 7 days, constantly holding those 2 temperatures. At the end of those 7 days, they're taken out and they're held at arm's length with certain lighting conditions, and determined if there's a fog that's noticeable on the glass surfaces. Here again, we have this lamp that shows in the bottom here of the diagram. This lamp, the height was never clarified. Sometimes the socket that the lamp went into was raised up, and so it brought the UV closer to the unit. So we try to maintain that to a certain height now, as that's clarified in the standard. Some people weren't using the proper voltage for the lamp that's specified at 230 volts AC. Some were using 120 roughly. And that's now specified. That would affect what your UV output and your heat output is. And then also the UV meters options were included as well, just as we did for the 2188 test, to allow more modern digital meters as well as this older analog meter. With respect to internal components, now these are the components that are inside the airspace. Typically, these are Munson bars, but they could be art glass and blinds, like I was saying. The Munson bars originally had 4 bars inside the unit. The size of this unit is 14 inches by 20 inches. And having 4 bars in there was considered to be overloading it with too much material. So we've reduced that to kind of reflect better the ratio of how much you typically would see in that size unit. So now it's just 2 bars, one horizontal and one vertical. And they're offset so that the chill plate can go right in the center here. Well, that's been done. We've reduced that to 2 bars from 4. We now allow components in this standard. You could always test them, but they weren't really in the standard. Now it does incorporate art glass and blinds, and talks about when you insert those, you put them in the proper proportion that you would see in the insulating glass unit when it was installed. And there's been a lot of controversy about fog inspection. There was thoughts that it was too subjective. The task group is still working on improving this, but at this point, we did not make a change in the proposed standards that were made, proposed drafts that were just balloted recently. Okay. As I said, that's the 2190 standard, this next slide, which is the specification that ties those first 2 standards together, and really is the heart of the certification process, E2190. within this, the changes that are made are we're going to decouple the internal components I just talked about in E2189 and introduce something called a base set. This base set will have no internal components in it, and that will have to be passed first. It'll have to go through the high humidity and weather cycling in 2188, and it will have to go through a fog test as well to test the seals and the desiccant and the spacer, but there will be no internal components in that fog test. So that will be your baseline set. Once you pass that, then you can do individual testing of whatever component you want to put inside there. You'll have to use the same baseline set, spacer, desiccant, and sealants, but the thought is that you'll be able to test individual internal components. So if you want to offer a whole host of things inside of an insulating glass unit, you don't have to test each one to the same weather cycling. It's only for the internal components fog test. Prior to this, if you really wanted to certify blinds and art glass and various different kinds and mutton bars of various different kinds, you'd have to do a full testing of cycling and high humidity of all of those in addition to the fog test. So now all you have to do is just a fog test for any internal component. This specification also calls out how to do gas measurement, and there was some controversy about gas filling for triples. It wasn't quite clear how that was to be measured because you have two gases or two gaps to measure in addition to having just one for a double pane, but for triple panes, you needed to have two of them. So you had to measure both of those and you average each of those. And each of those cavities have to be greater than 50%. I'm sorry, the average of those cavities has to be greater than 50% in order to pass. Prior to that, there was some confusion about whether you average them or each cavity had to be 50%. There still was some discussion on that, but that's the way the standard is going to be now. Is it will be the average of the cavities has to be greater than 50% to pass. And there was also a revision to the report form that's in E2190. So again, in herding the cats, we had to go through 4 rounds of balloting. Balloting is not uncommon that you have to go through several rounds, but this was rather brutal because we had 1 negative on the first round in May of 2017. We had 16 negatives in August of 2017. We thought we had handled all those appropriately, and then we went to a 3rd round in 2018 and had 3 negatives. And then those did get resolved, but we had to go through a 4th round as well, where we finally got no negatives. That was in November, and those did finally pass. So with all these three ballots or 3 documents to go through, 2188, 2189, 2190, I'm happy to report that all of those passed and are now published as 2119 standards. The major takeaways, I've already touched on these, but these are probably the 4 main points to consider. You will have new standards issued in 2019. So those are the ones that should be referenced are the ones from 2019. Those are already out and available for publication. You can download them from ASTM. The procedures should have less variability. And I'm putting a big and here, there's more work to be done, but they will have less variability than we had previously. And number 3 is the specimens for muntins need only to have 2 bars in them rather than 4. That will help for internal components to pass. And then the internal components, this is probably the biggest one, this is number 4. The internal components are now decoupled from what's called a baseline set, so that you can test individual internal components without sacrificing any problems with your baseline set. So that's the insulating glass unit standards for those three that I mentioned, 21, 88, 89, and 90. The next slide here, I want to talk about the gas filling task group. Again, this is chaired by Randy Ernst, and I'm just kind of filling in for him on this report. Here there are two standards that are currently up for renewal. E2269 that was reviewed, as if you called my earlier statement that the 14 here refers to, that was last passed in 2014, and 2649 that was last passed in 2012. The first one is a gas chromatograph test for argon. This test is a destructive test in that you have to take a syringe or something to extract gas out of the insulating glass unit, passing through the seals or the spacer, withdrawing a sample, and then putting it into a gas chromatogram device like the one like the one you see here. That's a gas chromatogram device that will analyze the gas. And if you use what's called a carrier gas of helium, that will analyze the argon, the oxygen, nitrogen, and any other contaminant that might be in there. That methodology is rather, I won't say difficult, but it can be difficult to use if you're not expert at it. There is another test method or another technique that uses a argon carrier gas instead of helium, and that's been proven to have a little more repeatability, a little easier to use for labs. And we're trying to add that to that 2260.
+1 74043964428 is now exiting.
The other one, the 2649 test, that is the SES or spark emission spectroscopy is what SES stands for. This is, I guess I'll need to name it. This is we don't usually brand names, but this is the spark-like gas glass device that's used by the E2190 protocol. And there's some tightening up here that's being done as well. We're going to record all 5 readings. In the past, it was found that some labs were taking 5 readings, which is what you're supposed to do, and average them, but they were kind of averaging them in their head. So now we're going to have all 5 of those readings be written down to get a more accurate average of those and have recordings of them. They're going to improve the hazard warnings, and there's some various other verification improvements that we're still working on. I don't think those are going to get balloted quite yet, but we're working on trying to verify when is this device usable, when indicators for if it's in calibration or not. So there'll be some verification improvements on that. The task group is also looking at a new laser device that's also from Spark-like. That's what I'm kind of showing here. Yeah, I'm not going to speak too much about it, but we are evaluating that. This device, I will say, measures only oxygen and nitrogen, but it is non-destructive and it will pass through coatings. It will pass through laminates, where this device, the Spark device, does measure argon directly, as well as nitrogen and oxygen. However, it won't pass through coatings and it won't pass through laminate. So this obviously will give a little
+16145927663 is now joining.
This device will allow a lot more materials or specimens to be evaluated, different types of specimens, I should say. So that's kind of where gas filling is, and that pretty much ends my presentation. We do have a meeting coming up actually next week, next Monday. We are meeting in Houston. That's the main committee meeting. Both the main committee, the subcommittee, and the task group will be meeting in Houston on Monday. And then the following committee week will be on the 30th of March in 2020, and that will be in Boston. So I wasn't tracking here closely as I was talking for any questions that came in. Sarah, are you there? Did you look at?
Yeah. Yeah, we do have a couple questions that have been submitted through the chat already. The first being, when do you start using this standard as you are certifying glass? Does the standard start right now, or is there an effective date in the future?
Yeah, that's a very good question. It depends on the certification program. I know that IGCC, I believe, is starting in the theirs. I should know, but I think it's either first of the year. But they will tell you from your program will. The other certification bodies should let you know. But
Is now exiting.
These standards, when you proclaim your certification, you would say that you are meeting 2190 2019, or you're meeting the 2010 standard. So talk to your certification. The short answer is talk to your certification body and see what they have adopted for when they will begin doing the testing.
Okay, great. And a second question, are point-supported holes in IGUs considered internal components for testing purposes?
Yes, they would be. You would need to test those for fog. So
Okay.
there is a bit of a gray area on that, because you have a hole there also, so you're also sealing it. So you'd probably have to test that in weather cycling as well as for fog. So that's a little bit different case here, but you would need to test those in both fog and cycling.
Okay, and a third question, has there been any discussion on krypton fill verification?
It's been discussed. Right now, we only cover argon, but it's certainly the devices can measure the devices I showed there can measure krypton as well. Certain ones can be done. Currently, it's not in the standard, but there has been some call for doing krypton gas as well as krypton blends and other exotic blends. At this point, we don't have them in the standard.
Okay. And another question, are units with capillary tubes tested?
Yes, they are allowed to be tested. You can have a capillary tube that's either closed or open, and those will also be tested.
Okay. Another question, do Muntin clips such as intercept clips get tested separately or as part of the Muntin configuration?
That's a good question. There is some discussion on how to adjust those. Those are currently considered to be a internal component. However, there is some concern that clips can affect the seals, and we are still grappling with that one. So that's a bit of a gray area at the moment.
Okay, great. Since we're just a little bit over time and there's no additional questions being submitted, we will conclude this month's webinar. Jeff, thank you for your time and preparation today and for also managing our technical challenges so eloquently.
+12069537452 is now exiting.
And we have been recording
Unknown
this.
participant is now exiting.
We have been recording this webinar and it will be posted on glass.org in the near future. Otherwise, we hope to see you at a future NGA Thursday webinar or in-person event.
Thank you, Sarah, and thanks for everyone's attention.
Thank you. Have a great day.
Multiple people are now exiting.